Hello everyone. Today we will be looking at system of linear equations in two variables and how to solve them using the elimination method. The topics we will be covering here is the elimination method to solve the systems of linear equations in two variables and also the graphical interpretation of solutions. So let's start. We're going to do it with the help of the examples. I will show you how to use the elimination method. But before that, I'm just going to have a quick recap of what is a linear system and what do you mean by having a solution. So remember, when we talk of a linear system is one which has more than one equation and more than one variable. Not only that, but also every variable has coefficient 1. Okay, so and here you have two equations, so that makes it a system, and then two variables, and when you solve these two together, you will get a value for x and y. So that when you look at the terms of the solution is given as an ordered pair because there are two variables. That means one for each of them, one for value for x, one for y. And when you look at this ordered pair, it has to satisfy both the equations simultaneously. In other words, when you substitute the values for x and y in the first equation, 3x plus y equals 2. And if you substitute x and y in the second equation, x minus y equals 6, it should satisfy it. So when I say the word satisfaction means that you plug in x and y, then the left-hand side equals the right-hand side. So for example, over here, we say 2 minus 4 is the solution to the above linear system. So the first thing we do is we write down these two equations as equation 1 and equation 2. So now we have to, this is the solution. That means when I plug these values in each of one of them separately, the left-hand side should equal the right-hand side. Okay, let's go ahead and do that. So let's first write equation 1. So now 2 is, remember, x representing and minus 4 representing y. So let's plug it in the first equation. So we have 3x plus y equals 2. And x will be replaced by 2, y will be replaced by minus 4. On the left-hand side, you get a 6 minus 4 equals 2 and a 2 equals 2. Yes, it is a solution, and it has also been proved to be true for equation 1. Now remember, for it to be a solution to the whole system, it has to satisfy both equation 1 and equation 2. So the equation 2 is x minus y equals 6. So let's plug the value for x and y here. So x is what? 2 minus of minus 4 equals 6. So 2 plus 4 equals 6, 6 equals 6. Great, this is the solution. Now we are going to use the elimination method. And this is much more easy. What the idea is this. In an elimination method is that when we have two equations with two variables, we try to cancel one of the variables. And the way we cancel out is, we look at the variables which is the most easiest to cancel. And after that, we also look at the coefficients of the variables value. Okay, so here in the first equation, it's the same equation as we did in the previous slide. So I'm going to show you when I solve it using the elimination method. From the previous slide, I know 2 minus 4 is a solution. I'm going to show you how we get it here. Okay, so the first thing we do is we look at individual equations. Okay, the first equation has 3x plus y, okay, equals 2. The second one has x minus y equals 6. Elimination means removing one of the variables. Now we can remove x or we can remove y. It does not matter. But the way to proceed is to make your life simple. So if I would prefer removing y. The reason is because when I add these two equations, plus y and minus y, have the same value of coefficient but opposite in signs. That makes it easy, isn't it? Okay, so we have made the decision we will cancel y. Okay, so in order to do that, that's in my head, I'm doing it. So when I cancel y, what I do is I draw a straight line between these equations and I add them. So I'm adding the first equation to the second. What happens here? Y and minus y cancel out. And what do we have? 3x plus x is 4x. 2 and 6, 8. Then you divide by 4 on both and you get x equals 2. So we have got one of the variables. Then we just have to substitute x equals to 2 in any of these equations. Once again, pick up the one which makes your life simple, guys. Okay, so here's it. We have x minus y equals 6. So I'm going to substitute in equation 2. I could do it in equation 1 also, but I want to have the least amount of work to be done here. Okay, so wherever x is this, so we have 2 minus y equals 6, minus y equals 6 minus 2, minus y equals 4, or y equals minus 4. So we have got the values for two variables. So what is the solution? Remember, when we write down the solution, guys, we have to write it like as an ordered pair, 2 minus 4. And this is exactly what we had seen in the previous slide. Okay, let's go ahead and practice a lot of these problems. Oh, one more thing before we go to the next one. Notice this one had a unique solution, that is only one solution. Okay, let's look at the next one. Here I have equation 1, x plus y 2, 2x plus 2y equals 4. Okay, so if I write this as equation 1 and equation 2. Now I have to cancel one of the variables. So if I pick x or y, that's fine. But the problem here is that both the variables here have positive signs, both the equations, and also we will have to do some kind of little, algebra here. So the first thing we're going to do is, if you make a choice, is okay, I am going to cancel x. In your head, you have to decide one of them. Okay, so this time we say, let's cancel x. Okay, that's in our heads. Now to cancel x, the equation 1 has coefficient 1, whereas the second equation has 2. So what we can do is, we can multiply the equation 1 by negative 2. Okay, so we will multiply this whole equation, the first equation, by negative 2. So what do we get? We get negative 2x, negative 2y equals negative 4. Now remember, equation 1, it doesn't matter if you multiply by a constant, the original equation still remains the same. So now we have two equations here, and now we're going to look at these two equations. Okay, so this equation is 2x plus 2y equals 4, and the next one is minus 2x minus 2y equals minus 4. We're going to add this one. What happens when we add? Everything cancels out. What do you see? A 0 equals 0. Now, when you get the scenario where a 0 equals 0, that means you have infinite solutions. And if you recall from your last section, where I explained when you have an infinite solution, that means the graph of the infinite solution, guys, looks like just one single line. And notice, this equation is a multiple, equation 1 here is a multiple of equation 2. Do you see that? That's a sure sign, just go with it. It's looking at also, oh, one equation is a multiple of the other, automatically infinite solutions also. Okay, now recollect one more thing, is that when we talked about solutions of linear system, we would either have a unique solution, and a unique solution, I forgot to show you here. In a unique solution, remember, what does that mean? That these two equations will basically meet at a point. So this is the point they will meet. That when you have a unique solution for a linear system, they actually have a point where the lines of these two equations will crisscross each other. That's it. Or they're going to have a meeting point. And when you have infinite solutions, guys, there is only one single line. Now let's look at the scenario. Remember, linear system has three possible scenarios: a unique, or infinite solution, and no solution. So I'm picking up the same examples we had done in section 5.1. But this time we're using elimination method and showing you. Okay, so this linear system is 4x minus 2y equals 3 minus 2x plus y equals minus 5. Write down equation 1, equation 2. Which one do you want to eliminate? You want to eliminate x or the variable y? Does not matter. So if I do x, that means I have to multiply the second equation by 2. Okay, so let's do cancel x here, because both of them have opposite signs. The only thing is the number value has to change. So we'll say, okay, multiply the second equation by the value 2. So what do you get? The two equations are 4x minus 2y equals 3. That's because the first equation is not needed to be changed. The second one becomes negative 4x. So this is what we are having. Plus 2y equals negative 10. Then we add the left hand side as a 0. What happens in the right hand side? 0 equals minus 7. No ways it's possible. That's meaning we have no solutions. And what does it mean graphically? Graphically means that we have two equations, and these two equations are parallel to each other. So it's like this. Okay, so suppose this is equation 1, I'm just saying equation 2. They are parallel to each other, remember that. Okay, so we have talked about the, once again, it doesn't matter what kind of a method are we using to solve it, a substitution or elimination. In both the scenarios, you would be getting only three possible solutions for a linear system. Once again, I'm talking about linear systems, a unique, no solution, or infinite solutions. So I have written it down in the form of a little table for you. So it says for a system of two linear equations in two variables, the number of solutions are either exactly one, which we call the unique. And if it's a unique, that means the two lines are intersecting at one point. If it has infinite many solutions, the two lines are coincident. That means there's only one single line. You see it in a graph. And no solution means two lines are parallel. Now, there's some definitions. If the system of equations is a system of linear equations is having a solution, we say the system is consistent when it has at least one solution. So in other words, if the solution is only one or infinite, so in these two scenarios, we are saying system is consistent. So we have a consistent linear system. On the other hand, if there is no solution, that means that the solution is the linear system is inconsistent. That's what it means. Okay, what does that mean? That the linear system is inconsistent. Okay, now we're going to do one example, is look at this and just try to look at these graphs and say, well, which one looks what? So these three graphs are given. We would like to know the number of solutions and whether it is consistent or inconsistent. Now, we have seen the graphs many times. If we have one single line, that means it is infinite solutions. And that means the system is consistent. Okay, when you have two parallel lines, that means no solution. The system is inconsistent. Okay, and when you have these lines crisscrossing or intersecting each other, crisscrossing at one point, okay, or intersecting at one point, that means you have one solution. That means the system is consistent. Okay? Now, we are going to solve a system of equations which have decimal points in it. So let's solve this one, a decimal point. Now remember, it's much more better to change it into integers and solve it. Now, if you have one decimal value after the point, that means you multiply the whole equation by a 10. So in this one, each one of the first equations, 0.2x and 0.6y, has a decimal point which has one number after it. So in this one, to make my life simple, I'm going to multiply it by a 10. When I look at the second equation, which is x minus 0.5y equals 2, once again I see one decimal value. So I say, oh, let me change it into the easy one, multiply by a 10. So let's solve this one. So when you multiply the first equation by a 10 and the second also, what do we get? We get 2x plus 6y equals negative 10. What about the next one? We get 10x minus 5y equals 20. Okay, now we would like to solve it. We have to cancel one of them. Now, I would prefer, now here again it is your choice, guys. You want to cancel the variable x or cancel the variable y. So when we look at it, if I want to cancel x, I will not only have to multiply by a different number, but I also have to use a negative. So that means I have to multiply by one of the equations by a negative so that the value remains the same, but then it has to have a negative. On the other hand, if I cancel y, I don't have to worry about changing the sign because the y coefficients have opposite signs. The only thing is I need to get the value to be the same. So that's what my choice is, to cancel the variable y. So in order to do that, I'll multiply the first equation so that I get the same value. So 6 and 5, what's the least common denominator? It's a 30, right? So that's one I need to get. So multiply the first equation by a 5 and the second one by a 6. So what do we get now? We get 10x plus 30y equals negative 50. Then we get 60x minus 30y equals 120. We add the two equations. What do we get? 70x equals 120 minus 50 is a 70, or x is 1. Okay, now we just can put x equal to 1 in either one of them. So I'm just going to put it on the first equation. So I say put x equal to 1 in this equation, 2x plus 6y equals negative 10. Mind you guys, you can put it over here or here or here or here. It does not matter. The only thing you have to keep is make your life simple, okay? So now let's substitute x here. 2 times 1 plus 6y equals negative 10. 6y equals negative 10, so this is 2 here, or 6y equals negative 10 and negative 2. So we get 6y equals negative 12, or y equals negative 2. So what's the solution to this linear system? X and y is an ordered pair. It is given by 1 and negative 2. Okay, one more example now. Okay, so in this one, you have to make the choice. So here's an example, 5x plus 6y equals 24, and 3x plus 5y equals 18. So we have to cancel one of the variables. You can either do x or you can do y. And it does not matter because in both of them, you will have to do one more thing, because both of them have positive signs, both the variables. You will have to multiply by one of the variables by a negative. So this time I'm going to say, hey, I'm going to cancel x. Okay, so in my back of my mind, I'm canceling x. Now, to cancel x, notice the first equation has a 5, the second equation has a 3. So we say, let's multiply the first one by a -3 and the second one by a 5, so that we both get at least, that means we get a 15, because we have to have the same value but opposite in signs. So multiply the first one by a -3, the second one by 5. Now guys, you could also have done 3 and -5. It would not have made a difference. The only thing is, it's a decision, however you want to proceed. So what do we get the new equations to be? -15x minus 18y equals -72. Then you have 15x plus 25y equals 90. So when you add these two, the x's cancel out. 25 minus 18 is a 7y. 90 minus 72 is 18. So y comes out to be 18 over 7. Okay. Now we can plug y equals 18 over 7 in either of these equations. So let's plug it in the first equation. So put y equal to 18 over 7 in 5x plus 6y equals 24. So we get 5x plus 6 times 18 over 7 equals 24. 5x is plus 108 over 7 equals 24, or 5x is 24 minus 108 over 7. You multiply 7 by 24, you get 168 minus 108 over 7. Okay, so I need to have some space and I can't even see what I have here. Okay, so 5x is 168 minus 108 over 7. 5x is 60 over 7. You multiply by 5, so 15 over 60 over 7. X is 5 goes 12 times, 12 over 7. So the final answer, solution is 12 over 7. X is 12 over 7, and what is, guys, y? Y was 18 over 7. Okay, so our solution to this linear system, so the solution is 12 over 7 and 18 over 7. Thank you.